try these examples on the mean value theorems. Suppose that we know that the function fx is a continuous and differentiable on the range of 6 to 15. And let's suppose that we know that f6 is equal to -2 and f prime x is less than 10. What is the largest possible value for f15? And we know that this is related to the mean value theorems. The equations for the theorem is given here. The range is given 6 to 15. That means the division here, it will be 15 minus 6. And the function here, it will be f15 minus f6. It is given that f6 is equals to -2. Substitute this to the functions of f6. And it is also given the s prime x is less than 10. This is the functions for the s prime x. And the entire formula here will have to be less than 10. From the function here, we will see that there is only one unknown. Solve the function here, you will get f15 less or equals to 88. The question asks us for the largest possible value for f15, and the largest value will be equals to 88. Let us try another examples for the mean value theorem. The functions are given here, and the range are given here. We will solve the questions one by one. This is the functions, and the range is 2 to 5. You need to differentiate these functions into h prime z. Substitute 2 and 5 into the functions of hz. That will give you 12 and 333. Use these formulas for the mean value theorem. Substitute c into the function here, you will get this. h5 minus h2 divided by 5 minus 2, as in accordance to the formula here. Solve the expressions, you will get c equals to 3.6294. Check the value here, which range in between the 2 and 5. Next, we try the second question here. To solve these questions, copy the function here, differentiate the functions over t. Differentiating 7t will give you 7. Differentiating e power of -3t will give you -3 e power of -3t. Next, substitute the value -2 and 3 into the functions of at. The outcomes are given here. Use the formulas of mean value theorem, where fc is the differentiations of at, which is here. a3 minus a -2 divided by 3 minus -2. Solve the equation here, you will get this. Next, you need to eliminate the e here. This is done by long the entire expressions here. Based on the principle of long, you can bring this forward to the front of the functions. Ln e will give you 1. And solve the functions, you will get t equals to -1.097. Check with the range, and these numbers fall in between the range of -2 to 3. And this will be the solutions for this example. Let us try one more example for this. It is given that the functions fs is continuous and differentiable within the range of -7 and 0. It is given that f -7 is equals to -3. Differentiations of the x will be less than 2. The questions asks us the largest possible value for the f0. Use the formulas of the mean value theorems. Given f -7 is equals to -3, the range will be -7 to 0. That means you will have to minus the functions 0 to functions -7. And then 0 minus -7 as given in the range here. Substitute -3 into the functions of -7, and it is given that the differentiations of the x is less than or equals to 2. That means the whole function here is equals and less than 2. If you substitute the relevant value into the function here, the only unknown will be f0. Solve that, you will obtain f0 less or equals to 11. The questions asks us to determine the largest possible value of f0, and in this case, it is equals to 11.